आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज आपकी आवाज, विज्ञान की आवाज, की आवाज।
Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics, and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Radioactive Community Radio, Bengaluru.
एक नई दुनिया की आवाज आपकी आवाज, विज्ञान की आवाज, की आवाज, की आवाज।
Latest information on STEM popularization.
Startup incubated at IISC develops test kit for sickle cell. A health tech startup incubated at Society for Innovation and Development of Indian Institute of Science has developed Sickle Cert, India's first indigenous diagnostic kit for sickle cell anemia. The firm Shamuka Innovations has also developed a screening test kit called Sickle Find. The technology provides an affordable and efficient solution to screen large populations as a point-of-care test for sickle cell anemia. The high-performance optical spectroscopy tech, consisting of test kits and portable analyzers, was developed by researchers at the Indian Institute of Science. The technology has been licensed to Shanmuga for commercialization, said a statement. Further, a companion smartphone application that comes with it enables digital data recording, analysis, and integration with various registries, Ayushman Bharat Health Account, and other cloud-based patient health record systems. With a tiny amount of blood from a finger prick, the test provides highly accurate results in 15 minutes. In batch mode, more than 40 samples can be tested in an hour, enabling a large volume of screenings to be completed in much shorter time span, said Professor Sai Shiva Gurti, lead inventor of the technology and associate professor at the Instrumentation and Applied Physics Department, IISc. Union Secretary of Department of Science and Technology, Dr. S. Chandrasekhar, on Friday virtually inaugurated the technology innovation in exploration and mining, TechSmen, a technology innovation hub at IIT Dhanbad. The Union Secretary lauded the technologies developed by TechSmen, including the cutting-edge telematics platform that enables real-time monitoring and optimization of vehicles and asset movements in mines. The web-enabled illumination, surveying equipment, and the AI-powered e-surveillance system, which ensures greater safety and enhanced efficiency of workers, and called upon the researchers for further development of technologies at advanced level to ensure its further use at larger scale by garnering more funds.
Now, our next segment is Analyst in STEM. Today, we are with Professor Subir K. Das, Professor, Theoretical Sciences Unit, Jawaharlal Nehru Center for Advanced Scientific Research.
I work in a area in the area of phase transition and critical phenomena.
Okay.
And it's a very vast area.
Okay.
And I have been involved in several different aspects of phase transitions in a large variety of systems. I'm a theoretical physicist.
Okay.
And in that broad area, alongside few other things, a major focus in my group in JNCASR is on a very interesting topic that is known now as the Mpemba effect. And if I ask you a question like you have a hot sample of water and a cold sample of water, and simultaneously you put both the samples inside a refrigerator, and then if I ask you, can you make a guess which one will freeze faster between the two? I'm sure your answer will be the colder one.
Cool.
But it is the opposite. The hotter one freezes faster in overwhelmingly large number of situations. This is a major topic of my research, not directly this particular problem. So this boy, after whom it was named, he passed away unfortunately this year in 2023. When he was a school child, he discovered this thing. His name is Erasto Mpemba from Tanzania. And now people are trying to generalize this thing. So he observed in water or while preparing ice cream, it's kind of with the system of with milk. And now in my group, we have observed in pure magnetic systems. So magnets can have, for example, two different phases. One is paramagnetic phase, where if you do not have any external magnetic field, net magnetization of your system will be zero. On the other hand, there is something called Curie point. Below that, the system can have spontaneous magnetization even when the external magnetic field tends to zero. And then we ask the question, in the paramagnetic phase, you prepare your system or sample at various different starting temperatures. Some are higher, some are lower. Then if you quench them all of a sudden to a temperature below the Curie temperature, which one will become ferromagnet first? Again, the common answer will be the ones which are colder.
Yes, sir.
Okay, but it happens the opposite way.
Sir, how is your research useful for a common man or in the field of science?
Like it can have lot of applications in memory devices, for example. In some way, while exhibiting such kind of phenomena, the system may be trying to forget its initial memory, and that's what is giving rise to this interesting phenomenon. And other thing like new designs of refrigerator for cooling purposes and all. So these are the applications that I can immediately think of.
Sir, can you give some insights on the history and also the present development and also the future scope of this particular research?
History, I already told you briefly. But let me go back even. Now, this fact was known to people even in the time of Aristotle, that is 4th century before Christ. Aristotle wrote in his Meteorologica that something like to cool or freeze water quicker, heat it a bit. And over the period of time in different centuries, great people spoke about it, and the fact was often also forgotten. And most recently, it was discovered or rediscovered, whatever you say, by Erasto Mpemba when he was a schoolboy in Tanzania. There was a cookery class. In 1963, it happened. In that cookery class, the task was to prepare ice cream. Then two friends, one of them was Mpemba. They're using the what happens for the preparation of ice cream? Typically, you buy milk from market and get it from wherever you can, and then you boil it. In my understanding, it is to this boiling part is to degerm the sample, and then you bring the sample, bring the hot milk to room temperature, that means wait for a while, and then add sugar and other ingredients before putting inside the refrigerator. Then what happened on that day, they probably needed to attend another class, and Mpemba's friend was using the oven. What I'm saying, basically Mpemba didn't have enough time to heat it and bring it down to the room temperature, so he put his hot mixture inside the refrigerator. On the other hand, his friend put cold mixture, room temperature mixture inside the refrigerator. And after a while, when Mpemba came to check what happened, he found that his hotter sample became ice cream, but his friend's colder sample did not become. And he asked this question to his teachers, friends. They didn't believe him, even though, it was known since the time of Aristotle at least. And then Mpemba came in contact with one university professor who came to deliver a lecture in his school, and then he described what he has observed, and then later, milk shares a lot of phase transition related properties with water. So they performed the same experiment with water, and they found the same thing, and since then it is known as Mpemba effect. So that's the brief history. And in recent times, particularly since last 10-15 years, 1 or 2 decades, people have been actively involved in understanding the effect, because it defies a lot of our common sense, and there exists no appropriate theory to explain this fact. So I am also trying to understand theoretical and computational studies of various model systems so that the experimental facts can be replicated.
Sir. Sir, considering the research work, in terms of ranking, where does India stand?
Well, my area is, I do a lot of other things in the domain of phase transition. In this broad domain, India has a fairly good standing, but if we compare with the very developed Western world, then we are certainly far behind. But if we take the case of Mpemba effect, I told you that only in last 10-15 years people are getting more and more interested to understand this effect. So not too many groups, but but the size is growing rapidly. And 2 groups already, or 2 or 3 groups I would say, into it from India. And we are doing pretty good job in terms of publishing and understanding.
Sir. Sir, do you find yourself having any competition, and if there are, who are they, sir?
I would say in real sense competitor, if at all this is healthy competition, this effect needs to be understood, and it can have a lot of practical applications. That way we need more and more people to join. But if you call it really a competition, then from India there is somebody called R. Rajesh from Institute for Mathematical Sciences in Chennai, and then there are groups from Israel, from United States, Canada, from China. So many countries are now catching up.
Can you brief about contemporary research?
So for example, I said I am interested in primarily I started my work in this area from magnetic system. Okay. I gave you the example of para to ferromagnetic transition. Now I am investigating in getting this thing in active matter systems, for example, and water also. I am directly investigating the effect, the original system that exhibited this effect, and then people all over the country, they are getting interested into other types of systems. For example, there is something called spin glass, There is also kind of a magnetic system. Then granular matter. Granular matter, its size span a very wide range. These dust particles are granular particles. Then big chunks of stones, those are granular particles. So whether such kind of effects do exist in granular matter also. So I personally am interested in active matter, water and magnetic system at the moment, and I'm extending my domain by including the granular matter also.
Okay. How is Indian industries associated with this project?
This is again coming back to the point that I mentioned, only for last 10-15 years people are getting into it. And from India, first publication came in 2020, I guess, probably 2020, and I published my first paper in 2021. So it's too early to get the industry involved, and at this point of time it is basically starting from fundamental perspective. And I believe in future, I told you the applications like refrigeration, then memory effect, etc. There can be a lot of device related applications. Industry may come up. It's too early because the phenomena is interesting, but we are into it very early.
Here we are, signing off. Stay tuned with us to catch up on the latest science updates and learn about STEM experts.